Today I'm going to talk about a project that was funded by the Northwest Indian Fisheries Commission and Salmon Defense to create a seafloor habitat map for the waters off of the Olympic Peninsula. And it's also a not so thinly veiled advertisement for the Coastal and Marine Ecological Classification Standard and how it can be applied region-wide. So the need. There are the coastal treaty tribes that are located in Washington state are co-managers of about 6,000 square miles of Pacific Ocean waters off the coast of the Olympic Peninsula. They work with their US partners to coordinate scientific research and ecosystem based management processes to support their management of fisheries, as well as to help them do coastal and marine spatial planning. They need spatial data to support their resource management and decision making. And they found that the existing data in the format that it was available was not really adequate to meet their needs. So to address this problem, they worked with NOAA, the folks at the Olympic Coast National Marine Sanctuary, and the Northwest Indian Fisheries Commission to be able to, and they asked NatureServe to help them aggregate and standardize existing data sets so that all of the data were speaking the same language. So the objectives of this project were to bring together existing spatial habitat data information into a common framework worker terminology, and we used the CEMEX classification for that, to provide a consistent nomenclature for the units, and then to create seafloor maps and spatial data products. And we at NatureServe were interested in it because we were really curious to see how well the Coastal Marine Ecological Classification Standard would be for application to a number of different data domains and at a larger regional scale. So there's a lot of data available for this area, and none of it talks to each other, or it didn't until now. There's information on sediments, geomorphic features, bathymetry, and other aspects of the seafloor. They've been collected in a number of different ways with a number of different methods, and with at least 4 different classification standards that were applied to the various data sets. We were just really fortunate that Dr. Chris Goldfinger and his colleagues at the Oregon State University, they did a lot of the heavy lifting on this. They compiled much of the existed data into what they call the Spatial Geologic Habitat Map. And we had that as a starting point, so that was really awesome and lucky. The data themselves are available for Washington, Oregon, and the Northern California coasts. And so we use that data set. The resolution in the data set varies from very fine to very coarse, but they assembled it together nonetheless. And it provides sort of a measurement of how well, what's known and what's available, and it also shows what we don't know. When I show you the data, you'll see that. So our job was to bring these data together into common terminology. I'll just say that we used just the existing lines that were in the shapefiles. We didn't remap anything. We just tried to classify it and translate it into the common terminology. So I'll just give you a quick overview of the Coastal Marine Ecological Classification Standard, or CEMEX, as you'll hear that. That's our acronym. What is it? It's the US federal standard that's available now for classifying, describing, and mapping ecological marine communities or habitats. It was published in 2012. It's that common language for describing marine ecosystems, and it does provide this framework we needed for organizing observational information. The CEMEX framework is composed of settings, the biogeographic setting and the aquatic setting, which are really larger geographic and environmental context for what we call these components. There are these 4 components which represent different aspects of the seascape. So the water column component is based on the water column stratification and structure and chemistry. The biotic component is based on the living biota on the bottom and in the water column. The substrate component is based on the particle sizes of the substrate, and the geoform component describes the geomorphology or the shape of the seafloor. So we can assemble these the units from these various components to create ecological marine units. And you're like, wait a minute, I heard about ecological marine units before, and they were just based on the water column. And that's true. The rule for creating ecological marine units is just that you have to combine data from a number of different abiotic factors to create a combined or derived unit, which is, as I said, a combination of things. Since the source data set was based only on substrate and geoform components, we only dealt with that in this particular project. So, just to give you an example of what the units might look like, a sand substrate unit plus a beach geoform unit would equivalent of a sand beach EMU. So it's not rocket science, but it is pretty helpful in terms of having a consistent terminology for naming the units. So we had a data set that had about 109 different units in them based on those 4 classifications. And so I sat down and studied the definitions in CEMEX and studied the definitions in the source classifications and crosswalked all one to another. And what we found is that sometimes they matched, and that was awesome. And sometimes the concept with the definitions matched, but the names were different. In those cases, we just identified what the synonymy was, and we marked a CEMEX name on an equivalent unit, and that was a no-brainer. Sometimes the concept of the unit or the definition was broader than the CEMEX unit. And even worse, it might have been broader than the CEMEX unit, but had the same name as the CEMEX unit, so they weren't equivalent. So we had to deal with that. We had some that were finer in concept, and we had some that there was no equivalent in CEMEX. So in terms of solutions, we identified synonymy. We developed a methodology for creating equivalencies by adding 2 types together. There's the concept in CEMEX called co-occurring elements, which identifies that there's a majority of a particular unit in one polygon, but it might have some other things. So like in their case, cobbly boulder is boulder, mostly boulder with some cobbles. So that's it. And then if there was just nothing in CEMEX, we encouraged them and we created what we call provisional units. And then we will, CEMEX is a dynamic content standard, and it's it's generated by our peers, so we can, by the community. So you can create and suggest units for the new classification. So we did that. And I'll just say that classification crosswalking is messy no matter what. There's no Rosetta Stone that makes it perfect. So we did our best to just sort of document our confidence that the relationships that we were identifying were the same. For the spatial data, we applied the CEMEX units to the shapefile. We derived the rasters from the shapefile using a feature raster conversion in ArcGIS 10.3.1. We did it we completed about a year ago. And our end products were CEMEX compliant geoform substrate and ecological marine unit maps. We used the raster format itself facilitated the visualization and mapping of the large data set, and the 30mm resolution ensured that the fine scale and coarse scale units both were accurately represented. So here are the first 2 maps. I'm just showing you the Washington portion of the data set. It goes all the way to Southern California, and you'll see that. I mean Northern California, but you'll see that in a second. You can see on the left the substrate map. There's a lot of, if you can see, how do I, is there a point, is there a, well, we're here. You can see there are some areas where there's really fine resolution, where it looks like somebody took a lawnmower across the substrate map there. You can also see some really fine resolution rocky outcrops on the coast where those are very finely sampled. And then you can see just a whole lot of mud out towards the coast where not very much is known. And the sampling was done at a much coarser scale. You'll notice that those same the lawnmower pattern is not on the substrate map on the right because those data weren't collected at that level of scale for that particular project where they were assembled. Remember, this is from 19 different data sets, so it's just a big Frankenstein stitched together product. So finally, we created this ecological marine unit map. This is, I think there's on the order of about, I can't remember how many. Well, you can see there's quite a few more combinations of features here. So the idea is to say, can identify the physiographic or the geomorphic positioning of the unit along with its substrate counterpart. So these are all the unique combinations using the consistent framework of CEMEX. And it worked pretty well. There are very few really messy issues to deal with. Let's see. Okay, and there we go. Lessons learned. It provides an important tool for standardizing and data, so CEMEX worked for us. Having that pre-aggregated data was a huge benefit. It'd be a lot better if data producers could contribute directly to an aggregated data set. We're really interested in Esri's new ArcGIS hub that has a promise for making aggregating and sharing data easier so that people can hold on to their own data and share it to the group. And if you use CEMEX from the beginning, that's even better.